At around $2 billion apiece, every B-2 is one of the most expensive warplanes in history. Only 21 have ever been built, and each one carries secrets you'll hardly believe. The B-2 Spirit looks like it flew straight out of a sci-fi movie, but its flying wing design and radar-absorbing materials make it nearly invisible to the world's most advanced air defenses. Today, we'll peel back layers of security, engineering, and cutting-edge materials to see how it's done. But before you can even think about building a bomber like this, you have to get past some of the strictest security on the planet. Stick around. This is a story you don't want to miss. And if you're into content like this, a quick like and subscribe helps more than you know. Inside the B-2 Spirit's factory, the way security works is almost as unique as the plane itself. The entire operation runs on extreme secrecy, with every process split into tightly controlled segments. Workers only see a sliver of the bigger picture, just the part they need to do their job. This system, called compartmentalization, keeps each person focused on a narrow task and makes it nearly impossible for anyone to piece together how the whole bomber comes together. Every employee is assigned to a specific area, and moving outside of that zone isn't just discouraged, it's blocked by layers of high-tech access controls. Badge scanners decide who goes where, and 24/7 surveillance teams keep an eye on movement throughout the facility. The goal isn't only to keep intruders out, it's to make sure that every bit of sensitive information stays locked down. Even the layout of the building is designed to keep teams separated, so no one can accidentally stumble onto something they shouldn't see. Inside these secure zones, the rules are just as strict. Workers must clear separate security checkpoints to move between different parts of the factory. For example, if you're working on part of the wing, you have no idea what's happening in the section handling radar-absorbing materials. Each group stays in its lane, and only a handful of people ever get a glimpse at how all the pieces fit together. This approach slows down the process and demands a lot of trust in the system, but it's the only way to protect the bomber's secrets. Communication between teams is tightly controlled too. Encrypted systems let workers share just enough information to keep the project moving, but never more than they need to know. Even routine updates are filtered and monitored, so nothing slips through the cracks. The result is a strange mix of teamwork and isolation. Everyone is working toward the same goal, but almost no one has the full story. A dedicated counterintelligence team is always on the hunt for threats. Their job is to scan for foreign espionage, both inside the factory and across digital networks. They watch for anything out of the ordinary: suspicious emails, unusual data transfers, or signs that someone is trying to sneak information out. The rules are strict: no phones, no recording devices, and no unapproved electronics anywhere near the production floor. Monitoring systems pick up on any odd signals that could point to hacking attempts or hidden cameras. All data moves through heavily encrypted channels, making it almost impossible for outsiders to intercept. But the secrecy doesn't stop at the factory doors. The supply chain is just as locked down. Parts and materials show up from anonymous vendors, often in unmarked boxes, with each supplier handling only a small piece of the puzzle. Sometimes critical components are split into multiple shipments, delivered at different times or mixed in with other unrelated items. Many suppliers don't even know they're working on the B-2 at all. This makes it almost impossible for anyone, even someone on the inside, to figure out what's being built. And there's one little trick that even most insiders never see. More on that soon. All these layers of secrecy are there for a reason. If even a single detail slips out, it could give potential adversaries a way to counter the B-2's stealth. The cost of a leak isn't just financial. It could undermine the entire purpose of the bomber. That's why every process, from badge scans to encrypted emails, is built around the idea of keeping secrets safe. This intense focus on security shapes how the B-2 is built. Every worker is isolated from the bigger picture, and every material is tracked from the moment it arrives. There's no room for shortcuts, and mistakes are caught early because the stakes are so high. The process takes longer and the costs are higher, but these are deliberate choices. The payoff is a bomber that's not just hard to detect in the sky, but nearly invisible in how it's made. Of course, secrecy is only part of the story. The real challenge comes from the B-2's design itself. Building an aircraft with no tail and no traditional fuselage isn't just a security puzzle, it's a massive engineering challenge. When you look at the B-2's spirit, what stands out isn't just its strange shape. It's how every inch of the aircraft is built for a single purpose, to avoid detection. The flying wing design, first imagined by Jack Northrop in the 1940s, was always a bold idea, but making it work on this scale took decades of technological progress. The B-2 is basically one enormous continuous wing, with no tail and no traditional fuselage to fall back on for stability. That means the entire aircraft has to be engineered with a level of precision that's hard to grasp. The real test starts with keeping the B-2 stable in flight. Without a tail, the aircraft wants to yaw and pitch unpredictably. To solve this, engineers turn to a fly-by-wire system, a network of computers and sensors that constantly monitor the B-2's position and make tiny corrections hundreds of times per second. This system is the only reason the B-2 doesn't veer off course or become impossible to control. It's not just about keeping the plane level, it's about making sure that every part of the aircraft responds exactly as intended, every single time. This demand for precision doesn't stop at the software. The physical construction of the B-2 is just as unforgiving. Every panel, joint, and fastener has to line up so perfectly that tolerances are measured in thousandths of an inch. Even a tiny misalignment can throw off the aerodynamics or create a seam that bounces radar waves right back to an enemy's sensors. To get this right, engineers rely on advanced computer-aided design systems to model every part of the aircraft before a single piece is built. Then robotic assembly systems and laser-guided tools take over, placing each component exactly where it needs to be. If a section is even slightly off, production stops until the issue is fixed. It's a meticulous process, but it's the only way to ensure the B-2 stays invisible and flies as designed. Let's talk about those massive wings. Building a wing this large out of carbon graphite composite materials is no small feat. Each section is manufactured separately, then joined together with near-flawless accuracy. The seams between these sections must be practically invisible, not just to the naked eye, but to radar as well. Laser-guided alignment tools help position every piece, and teams check the fit over and over before moving forward. If something doesn't line up, it isn't just a minor inconvenience. It can mean pulling apart huge sections and starting over, adding time and cost. But it's necessary to protect the aircraft's stealth. Every aspect of the B-2's shape, from the gentle curve of its wings to the smooth transitions between panels, is designed to scatter or absorb radar waves. There are no sharp corners or exposed hardware anywhere on the surface. The design minimizes any features that could reflect radar, making the bomber appear almost invisible on a radar screen. At the same time, the aircraft has to be efficient enough to fly thousands of miles without refueling, so engineers have to balance stealth with aerodynamic performance. Customization is the rule, not the exception. Most parts of the B-2 are built specifically for the aircraft. Off-the-shelf hardware just doesn't cut it. Even the smallest access panel or internal bracket needs to fit perfectly and meet strict requirements for weight, strength, and radar signature. That means most components are made in-house or by trusted suppliers, all working under tight security. The entire supply chain is locked down to prevent leaks or mistakes that could compromise the aircraft. Mistakes aren't just expensive, they're a threat to the mission. If a radar test shows that a section of the aircraft is reflecting more than it should, engineers have to go back and fix the problem no matter how much work it takes. Every part of the B-2 is inspected and tested, sometimes multiple times, to catch even the smallest flaw. The goal is always the same: perfection, because that's what keeps the plane and its crew safe. All this precision leads to the next major piece of the stealth puzzle: the materials and coatings that cover the B-2's surface. The design alone isn't enough to keep the bomber hidden. The real secret to its invisibility lies in the radar-absorbing materials that form its outer skin, a layer that's just as critical and just as challenging as the engineering underneath. What really sets the B-2 apart is the science built into its outer layer. The bomber's stealth relies on radar-absorbing materials, RAM, coating its entire surface. Instead of bouncing radar waves back to detection systems, this coating soaks up the energy, making the B-2 appear on enemy screens as nothing more than a small blip, roughly the size of a bird. That's the secret sauce that lets it slip through the world's most advanced air defenses. Creating RAM that actually works is a huge challenge. Scientists had to develop compounds that could absorb radar across a range of frequencies, stay lightweight, and survive everything from freezing altitudes to the heat of high-speed flight. But it's not just about inventing the material, it's about getting it onto the aircraft perfectly. The application process is so sensitive that even a fingerprint can ruin a section. Imagine a technician in a clean suit, inside a climate-controlled room, carefully spraying or brushing on the coating. If a smudge or dust particle shows up, that area gets stripped, reapplied, and re-inspected. This isn't just for show. A tiny flaw could mean the difference between staying hidden and being spotted. Every square inch of the bomber's skin is checked and rechecked. Specialized tools and lighting help inspectors spot any imperfections. The process is slow, but that's what it takes to make sure nothing slips through. Technicians go through strict protocols, wearing gloves and using only approved equipment. The clean rooms themselves are kept spotless with filtered air and tight controls on temperature and humidity. It's a little like prepping a spacecraft, no shortcuts allowed. Underneath all this is a layer of secrecy. The actual formula for the RAM is classified, and even the technicians applying it often don't know exactly what's in the mix. Their instructions are detailed, but the bigger picture stays hidden. This compartmentalization keeps the technology safe from prying eyes. Even the way the coatings are tested is kept under wraps. But what we do know is that new versions are constantly put through their paces using actual radar frequencies. Each update has to prove it can stand up to the latest detection tech before it's cleared for use. The B-2's RAM isn't a one-and-done deal either. Over time, the coating gets exposed to rain, wind, UV rays, and the bumps and scrapes of regular use. That means maintenance is a non-stop job. After every mission, crews inspect the entire surface, looking for chips, scratches, or worn patches. When they find something, out comes the specialized equipment, and the process starts again, cleaning, prepping, reapplying, and testing. It's expensive and time-consuming, but it's the only way to keep the bomber's stealth edge sharp. Sometimes, damage shows up in places that are tough to reach. Technicians use specialized tools and even custom platforms to get at awkward angles or tight spaces. Each patch has to blend perfectly with the surrounding area so the RAM's absorption properties stay consistent. If the layers don't match up, that spot could reflect radar and give away the plane's position. That's why the process is so strict. There's no room for error. The cost of keeping the B-2 invisible isn't just in the high-tech materials, but in the constant upgrades. The RAM used today is far more advanced than what went on the first B-2s back in the 1980s. New chemical formulas, better application methods, and improved testing all add up. Each upgrade means more training for the technicians and more checks to make sure the new materials work as promised. But the payoff is worth it. A bomber that can slip past defenses that would catch anything else. For all the focus on technology, the real story is about the people who make this possible. Every flawless layer of RAM, every invisible seam, comes down to the skill and dedication of the technicians and specialists on the factory floor. Their work is precise, repetitive, and often done under immense pressure, but it's what gives the B-2 its edge. The next step in building this bomber isn't about machines or materials. It's about the team that brings it all together, one careful move at a time. Every major advance in the B-2's construction comes down to the people behind the process. Engineers, technicians, and specialists who put their expertise to the test every day. The workforce here isn't just highly skilled, it's highly trusted. After in-depth background checks, only cleared specialists handle everything from adhesives to composites. The hiring process is as selective as it gets because the integrity of the B-2 depends on both technical skill and absolute discretion. Each role fits into a tightly controlled system. Workers are assigned to specific areas and focus only on their designated tasks. This compartmentalization means a technician applying radar-absorbing coatings may never meet the engineer building internal supports, but both know their work has to be flawless. The stakes are clear. Even a tiny imperfection could compromise the aircraft's stealth. One technician might spend days smoothing a single panel to ensure zero radar reflection. Tiny errors could force hours of rework. Every step is checked and double-checked, and nothing moves forward unless it meets the strictest standards. Robotics and automation help with repetitive or high-precision tasks, but there are limits to what machines can do. Human expertise is what catches the subtle flaws that sensors miss. For example, a robot might apply a coating evenly, but only a technician's trained eye can spot a minute bubble or a hairline crack that could ruin the stealth effect. When tolerances are measured in thousandths of an inch, those details matter. It's this combination, machines for consistency, people for judgment, that keeps the B-2's construction on track. The pressure on the workforce is constant. They know that a single mistake could mean more than just extra work. It could jeopardize the mission. There's a real sense of responsibility in the air. Some workers spend hours inspecting a carbon composite component under magnification, searching for microscopic fissures. Others make sure an access panel fits so perfectly that it disappears into the wing. The pride they take in their work is matched only by the pressure to get it right the first time. Quality checks are everywhere. Every part that goes onto the bomber is inspected and tested. If something doesn't pass, it's sent back for repair or replacement. No shortcuts allowed. Repairs are thorough and the process is slow, but that's the price of perfection. Technicians know they're not just building an aircraft, they're safeguarding a national security asset. That sense of purpose is what pushes them to maintain such high standards, even when the work gets repetitive or stressful. Training for this job is ongoing. Workers go through hands-on workshops, simulations, and continuous learning to stay current with the latest materials and methods. They have to understand not just how to use advanced adhesives or handle carbon composites, but how those materials react under stress, exposure, and time. The goal is always to keep the B-2 at the cutting edge, able to adapt to new threats and challenges as they arise. The collaboration between humans and machines isn't always smooth. Sometimes a machine's output looks perfect on paper, but a technician will spot a flaw that only experience can reveal. Maybe it's a subtle texture difference in a coating or a faint misalignment that could create a radar hotspot. In those moments, human intuition and adaptability make all the difference. The best technicians know when to trust the data and when to trust their gut. Everyone involved in the B-2 project understands the weight of their work. It's not just about building something complex, it's about building something that matters. The sense of mission is real. Workers know their efforts let the B-2 reach targets across the globe, undetected. That knowledge drives a culture of excellence and dedication from start to finish. Final assembly is where all this effort comes together. Teams fit wings, apply coatings, and test electronics, making sure every piece works as a seamless whole. The result isn't just a plane, it's a product of thousands of careful decisions and skilled hands, each invisible to outsiders but essential to the B-2's success. In the end, the story of the B-2 is just as much about the people as it is about the technology. Their commitment, skill, and vigilance have made the bomber what it is today. And as new challenges emerge, it's this workforce that will keep pushing the boundaries of what's possible. From its flying wing shape to the radar-absorbing skin, the B-2 spirit shows how engineering can solve some of the toughest challenges in aviation. Every detail is the result of decades of innovation and the pressure to stay ahead during the Cold War. But the story doesn't stop here. The B-21 Raider is on the way. designed to be smaller, more affordable, and built for a larger fleet, expanding stealth capability beyond just 21 planes. If you enjoyed this inside look at extreme manufacturing secrecy, like and subscribe for more deep dives into engineering marvels. What would you want to see next inside America's most secretive factories?